Hey guys, welcome. We are going to be looking at some parabola notes. So you're going to want to write these down because this is going to be crucial information for you for the test. Okay, so we have looked at parabolas in Algebra 2. Basically a parabola is that quadratic graph where it like goes up and then it comes down. Okay, so kind of like a U shape. You're used to seeing a parabola written as ax squared plus bx plus c equals 0. It's called quadratic. But we're going to be looking at a different way of graphing a parabola, and this is a more precise way to graph a parabola. And this is the method or the way it looks. So basically we have 4 different ways that it looks. Now you don't actually have to write all 4 down, but for the sake of the first time doing this and your notes, I would write these first 4 down. Okay? So, what are we looking at? First things first. What is squared is going to tell us which way it's opening, up or down, left or right. And this is how we're going to tell. So if the y is squared, it's going to be going to the right or to the left. Okay, so it's going to be opening to the right or to the left. If it's x squared, this is our traditional up or down. So it's going to be facing up or down. And then left or right. Think of if you're opening to the right, I don't know which way that would look in the thing. I think that's going to the right. It looks like it. Then you have a positive 4p. So if you look right here, our 4p is positive, and we're going to the right. But this one, it's negative, so it's going to the left, which the left is the negative values. Okay? Parabola open, positive 4p. Parabola down, negative values, negative 4. Okay? And then the h and the k is the vertex. Okay, so what's the vertex? hk. It's very similar to our circle formula, right? hk was in that formula, and there was our center of the circle. So hk is the vertex, so it's the point in which the parabola changes direction. So the vertex would be right there if the parabola is going like that. P is the distance from the vertex to the focus, and it's the distance from the vertex to the directrix in the other direction. It sounds like I'm saying mumbo jumbo, so let's go ahead and try an example. And this is the example I'm going to do, but I'm going to do it on paper. So hold on one momento. Okay, so now we are looking at this same problem, and what I like to do first and foremost is figure out which way is this opening and draw a picture. Okay, so y is being squared, so we know it's going to go left or right, and this is positive, so I'm going to open up right. So we're going to open up to the right. So my parabola is going to look something like that, okay, because y is being squared and this is positive. Now, I do like to write the equation right above it. Remember, it's h, and let's see, if I move this down, we might be able to see the equation. That's not the equation. Let's go. We said it's going to the right, so it should look just like that. Y minus k squared equals 4p x minus h. Okay? So I like to write the formula in the right version right above it, and it's opening to the right. Okay, so the first thing we can actually write is the vertex. So whatever you see in here, since they're negatives, we pull out the opposite. So the x value is right here, so that's going to be a -2, comma, a +3. So our vertex is at -2 on the x and +1, 2, 3 on the y. So that's my vertex. Now, on a Go formative, you won't be able to graph it, but you will be writing down these points. So that's why I'm writing these points down. You just won't be able to have the graph part. Okay, now, the other portions of this, the focus and the directrix, are going to be found using this thing called 4p. As we saw before, and I'm going to scroll back to it, p is the distance from the focus, okay, or sorry, from the vertex to the focus and from the vertex to the directrix. So let's find this distance p. Well, they're lined up right here. So if 4p is equal to 8, that means p equals 2. Okay, well, which way does it open? So if you know in a graph, this point right here on the inside is called the focus, and there's a line back here, and the line is called the directrix. Okay, so focus is a point on the inside of the parabola, and the directrix is a line behind. Okay, so since I know it's going to the right, I'm going to go from the vertex, I'm going to go 2 units, 1, 2 to the right, and there's my focus, and it's at 0, 3. And then 2 units behind it, so if the focus is to the right, because it opens to the right, the directrix is going to be behind it, 2 units back here, and the directrix is a line. Okay, and since this is an up and down line, it's hitting the x-axis, it's at x, -4. So the directrix is a line, so we're going to do right x equals -4. So you always have to do a line, don't just write -4. Okay, last but not least, so it looks like we have the beginning of this, but now my question is, I know the parabola goes something like this, right? But I don't know how wide it's going to go or narrow. Okay, so how do I figure that out? Well, let's look up here. Okay, the distance from, so right here, this is a 2, -2, 3 opens to the right, which we got, right? Here's my vertex, -2, 3. Since 4p equals 8 means p equals 2, which we got. The distance from the vertex to the focus is 2. Don't forget the endpoints of the latus rectum. Now, the latus rectum, first of all, hilarious name. The latus rectum is the distance along this line of the focus, which is the 4p. So from here to here should be 4p. So this is what I do, is I say, well, there's 4p, it's 8. Okay, so we're going to go 8 units right down, or sorry, 4 units down. 1, 2, 3, 4, then 4 units up. 1, 2, 3, 4. And those are the endpoints. So that tells me how wide my graph is. So from here to here is the distance of 4p, okay, which in this situation is equal to 8. Okay, and so the endpoints are going to be at 0, -1, and we're going to be at 0, 1, 2, 3, 4, 5, 6, 7. And that is how you graph. We're going to do one more. Just kidding, we're going to do maybe 2 more. Maybe 3. I don't know. 1 second. Let me up. Okay, so here's our next one. Okay, so here we see x is being squared, which means it's going to either go up or down, and this is negative. So this means we're going to have a downward facing parabola. Okay, so let's pull out our vertex. Before we do that, let's write what it would be. It's x minus h squared. So h always goes with the x. 4p, and this is y minus k. Okay. Now, since it's going down, it's actually a -4p. P can never be a negative distance anyways, which we'll get to. Alright, so first things first, what's my vertex? Remember, it's opposite of what it looks like, so if it looks like it's 4, my vertex is actually a -4 for the x value, and it looks like it's a -2, but it's actually a +2. So we have -4, 2. So 1, 2, 3, 4, 1, 2, there is my vertex. Again, recommend drawing this, always makes my life easier. Okay, the distance between the vertex and the focus is p, so we're going to set -4p equal to -12, which means p is going to equal 3. So I'm going to go 1, 2, 3 steps forward, which is going to give me right there. So that's at -1, 2. And then we're going to go 3 back. 1, 2, 3, and that's my directrix. And it's going through this line. It's another, oh shoot. Guys, I'm so sorry. I did this as if we were opening to the right, didn't I? Which is a mistake, because I'm not opening to the right. I just did it as I was doing the other one. Alright, I'm glad I made that mistake. Okay, which way should it be opening? Down. So where's the focus need to go? Well, if the vertex is here, right, the vertex is right there at the top of the parabola, the focus needs to come down 2, or sorry, 3 points. I'm so sorry. So I'm going to come down 1, 2, 3 points. There's my focus. I'm so sorry. So that's at -4, comma, -1. Hopefully I didn't lose all of you yet. Okay. Then I find my directrix is going to be above that. So it's a line like that, and the focus is right there. So we're going to go up, 1, 2, 3, and there's my directrix right through there. Okay, so focus, we have my directrix, and that is going through a y value. So we're at 1, 2, 3, 4, 5, so this is y equals 5. So that's the line y equals 5. Okay. Last but not least is the endpoints, and remember the endpoints is the distance, or it tells us how wide or narrow it's going to be. And so for here it's the value of 4p, which is 12, which means it's pretty wide. So I'm going to go 1, 2, 3, 4, 5, 6 units that way, and then I'm going to go 1, 2, 3, 4, 5, 6 units that way. So there should be a total of 12 units, right, from here to here. So right there is 12 units, and that is my endpoints. And that distance right here is called the Latus Rectum. But the endpoints are at, so they're at the same y value of -1. Their x values are 2, and the other one is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And those are my 2 endpoints. Let's do one more for the sake of fun. Okay, example 3. We gotta figure out which way is it gonna open up. Y is being squared, so we know it's gonna go left or right. And since this is negative, we're gonna be going to the left. Hopefully I won't make a mistake like I did in the last one. So my vertex, let's write out y minus k squared equals -4p x minus h. Sorry about the dog noises. Okay, so opposite of what you see, it looks like -4, but it's actually +4. It looks like +1, actually -1. The x one goes first, so even though they flip-flop location, it's always the one with the x is going to go first, so it's going to be a -1, a +4. So you get -1, 1, 2, 3, 4, and we're going to go that way. Okay, so make sure I don't do this incorrectly. The focus isn't going to come down, it's not going to go to the right, it's going to go to the left because it opens up to the left. And so 4p, -4p equals -4, that means p equals 1, so we're just going to go 1 forward, right there, and then we're going to go 1 back for the line. Okay. Now my directrix this time is actually right on the y-axis, which is kind of unique. So my directrix is my y-axis. My focus is at -2, comma, +4. And then the last thing is the Latus Rectum. It's going to be a distance of 4 units, so I got to go up 2 from the focus and down 2 from the focus. And that's my graph like that. And those 2 points are at -2 on the x, but then they're going to come down from 4 down to 2, and -2, and they're going to go up from 4 2 more, which is 6. And there you go. Okay, so being able to graph those are going to be highly important. Actually, I think they're easier to graph than just having it in standard form because you can pull all the important stuff out. Again, the directrix on this one was kind of hard to see because it was the y-axis. If you go 1 back, and there it is. Alright guys, enjoy.